Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question with only one correct option on the polarization of light waves, in which we will solve a problem on the change in the intensity of a light wave transmitted through a Polaroid when it is rotated through a given angle. The question is as follows. Two beams A and B of plane polarized light with mutually perpendicular planes of polarization are seen through a Polaroid. From the position when the beam A has maximum intensity and beam B has zero intensity, a rotation of the Polaroid through 30 degrees makes the two beams appear equally bright. If the initial intensities of the two beams are IA and IB respectively, then the ratio IA by IB is, the options are 1, 1 by 3, 3 and 3 by 2. Before proceeding to solve the problem, let us recall the related concepts. First, let us discuss the polarization of light waves. The situation is shown in the figure, in which unpolarized light waves are traveling from left to right, which is along the positive direction of x-axis. The direction of the electric vector is randomly distributed in the yz plane, which is perpendicular to the direction of propagation. The wave is incident on the polarizer, whose transmission axis is along the y-axis. Therefore, the wave transmitted through the Polaroid has the electric vector pointing in the y direction. Therefore, we conclude that when unpolarized light is incident on a Polaroid, the transmitted wave is plane polarized with its electric vector parallel to the transmission axis of the Polaroid. It may be noted that the intensity transmitted by the Polaroid is equal to half the intensity of incident light. Now, let us discuss the law of Malus. It is about the intensity transmitted by a Polaroid when plane polarized light is incident on it. The situation is shown in the figure. OP is the line of polarization of the incident light, having the amplitude of the electric vector is equal to A, and OQ is the transmission axis of the Polaroid. The angle between them is equal to theta. Then it is clear from the figure that the amplitude of the electric vector transmitted by the Polaroid is equal to A cos theta. Now, intensity is directly proportional to the square of the amplitude. Therefore, if the intensity of the incident wave is equal to I, then that of the transmitted wave is equal to I cos square theta. Now, we can solve the problem in the question using these concepts. It is given that initially beam A produces maximum intensity. Therefore, line of polarization of beam A is parallel to the transmission axis of the Polaroid. And beam B produces zero intensity. Therefore, line of polarization of beam B is perpendicular to the transmission axis of the Polaroid. The initial position is shown in the first figure. Now, the Polaroid is rotated through an angle of 30 degrees as shown in the second figure. It can be seen that the angle between the line of polarization of A and the transmission axis of Polaroid is equal to 30 degrees, and that for beam B is equal to 60 degrees. Now, the incident intensity of beam A is equal to IA. Therefore, intensity transmitted is IA dash is equal to IA cos square 30, and the incident intensity of beam B is equal to IB. Therefore, intensity transmitted is IB dash is equal to IB cos square 60. It is given that IA dash is equal to IB dash. Putting the values and simplifying, we get IA by IB is equal to 1 by 3. Therefore, the correct option is B, which is the answer to the question.